Hello, this video is titled How do you answer questions using ionic and half equations? So again, I've done lots of videos on ionic and half equations, so therefore I'd recommend watching those first. This is kind of the final stage. Well, how do we actually put into practice our knowledge of ionic and half equations into a question? So I've got a question here for you, and it says, it's looking at a metal reacting with an acid. It says, using the reaction of zinc and dilute hydrochloric acid, write an ionic equation for the reaction with state symbols. Okay, and the first thing I would do is I would write out the full, you could start with the word equation. I'm just going to go straight into the balance symbol. I would have Zn plus HCl. I know that a metal plus an acid gives me a salt, and it also will give me hydrogen gas. Okay, so I've gone straight in with the balance symbol equation here. I'm not looking at the word equation. I would then, I should actually balance it. That would be my balance symbol equation. Okay, so now it's asking you to write an ionic equation. An ionic equation, that's part A there, is asking you to look at the reaction here, but just talk about the ions and their reacting. Okay, so that's what we're going to look at. Actually, what I should add, and I'll do that now really quickly, I should add the state symbols. That question always also asked that. Okay, so I've got my metal being a solid, HCl aqueous, AQ here, and a gas here. Okay, aqueous means in solution. Hydrogen gas obviously is a gas. The metal is a solid. Going back on to part A. And the reason I've added the state symbols here is because part A will ask you for the state symbols, and I can just carry them over from what I've got here. So going on to part A, the ionic equation. So we just want to look at what is happening with the ions from either side of the equation. Okay, so we need to look at the ions in zinc, HCl, zinc chloride, and hydrogen gas. Okay, so my next step, and I'll do it in a different colour at each step. Zn isn't an ion because it's in its elemental state, so it's just Zn. In HCl, I've got two ions, H plus and Cl minus. I'm going to leave the 2 there for now. That will come back in later. You don't have to. You can carry the 2 through. I like to add my 2 back in at the end, and you'll see why. We've then here got Zn 2 plus Cl minus. How would you know that? You'd have to, you actually in an exam have to know it by heart, but you would find Zn2 plus on your common ion sheet. And obviously hydrogen gas is just H2. At this stage where I'm constructing the equation, you will see that I haven't put it back in my state symbols yet, but I will do that at the end. Okay, so that's the first part of our ionic equation. That's how I like to set it out. We then have to remove any spectator ions. They are ions that have not changed from the left-hand side to the right-hand side. You can see here that Cl minus has not changed from either side of the equation. Okay, so therefore, here is the final answer to part A. Okay, so I've removed my Cl minus ions, my spectator ions. I have then added in my back in my state symbols. Now what I can do is I can add in the 2 from up here. Okay, I can just carry that down and put it here in front of my H plus. Okay, and that would be correct. Now we look at part B. It says, from your answer to part A, construct 2 half equations to show the electron transfers taking place. So that question there has actually given you a clue. It's told you what a half equation is. And a half equation is simply that. A half equation will show you what is happening in terms of electrons from here to here, and what is happening in terms of electrons from here to here. So let's start with do it in a different color. Let's start with Zn. Zn, we're going from here across the arrow to Zn2 plus. You need to think in terms of electrons. I'll just write oil rig here. Okay, we always need to refer back to oil rig. Oxidation is loss, reduction is gain. So what is happening to Zn from the left-hand side of the equation to the right-hand side? Well, zinc on this side is a neutral atom. Here it is turning into a 2 plus ion. For something to go from neutral to a 2 plus ion, it has lost electrons. So this is going to be our oxidation half equation. Okay. If we then look at where we would write electrons and where we would put them, oxidation is a loss of electrons. Okay. Now again, please watch my previous videos. When you're doing an oxidation reaction, we would put the electrons on the right hand side of the equation. Okay. So I'm just going to move that. So we write the electrons being lost on the right hand side. Okay, now you've got Zn2 plus there, and it means that it's actually lost 2 electrons to become a 2 plus charge. Okay, that is the balanced balanced half equation for the electron transfer from Zn into Zn2 plus. We're now going to do H plus into H2. This is still coming under part B, don't forget. It's 2 marks, 1 mark for each half equation. So in this, we're going from 2H plus to H2. Okay, so now we've got, again, you wouldn't have had to have carried over the 2. You could have just written H plus and then balanced it later, but I've just copied it straight over here. We've got 2H plus, so we've got 2 H plus ions turning into H2, a diatom, i.e. 2 H atoms bonded together. Okay, so what has happened to each H plus ion to become H2? Okay, well, if it's a positive ion and it's turning back into its neutral atom or diatom, it has had to have gained electrons. Now, if you weren't sure on whether it was oxidation or reduction, well, because this one is oxidation, the other half equation has to be reduction. Okay, so because I've written my oxidation electrons on the right hand side, I put my reduction ones on the left hand side. Now again, I've got 2 separate H plus ions, each gaining 1 electron, so I must put a 2 there. And that is your completed half equation to show you the electron transfer from H plus into H2. Okay, now part C, and I won't be able to write out the full answer here because it's 5 marks and I haven't got any room. So I'm just going to put some kind of pointers that you would want to put down. Okay, so for part C, it says explain why this is a redox reaction. So in that in that question, you want to be explaining, not describing. All of your equations thus far have kind of done the describing part. You now want to use words to explain, what is happening. Okay, you are going to want to talk about oil rig in there. Okay, you're going to want to talk about the fact that oxidation is the loss of electrons, which has happened here. Okay, and I'll put oil there to show that its oxidation is loss. And that's what's happened with the zinc. You then want to put the rig part, the reduction is gain part, talking about the 2H plus into the H2. So you'd want to talk about oil rig. You'd want to talk about how the zinc has lost electrons to become a 2 plus ion. You would then want to talk about how the H plus has been reduced to turn into H2. Okay, you would also really want to refer to, you could refer to numbers of electrons that is happening. So the fact that the 2 plus ion has lost 2 electrons, the H2 lots of H plus ions has gained 2 electrons. Okay, but you really want to focus your answer around oil rig. Okay, and what I will do now, so that you can actually see what should have gone into the part C, I will put the answer to this question on the next slide, and that will help you answer part C. So this is the mark scheme. You will see that obviously 4A and 4B, our answers are exactly as they should be. Just notice here that is a little bit of a typo. That 2+ should be higher. I think that's just a typo from this this place where I've got the questions from. So yeah, that 2+ should be a little bit higher there, but you can see our Ionic equation was correct. Look, 3 marks. You get 3 marks for an Ionic equation. 1 mark for the reactant, so that's over here. You get 1 mark for correct products here, and then another mark for your state symbols. So even if you forgot your state symbols, which I don't want you to do, you actually still get 2 marks out of 3, which is really good going. Again, our half equations are spot on. Now coming to 4C, so they speak about zinc ions being oxidized, hydrogen ions being reduced. They talk about the loss and gain of electrons. They talk about the fact that zinc loses 2, as we said. 2 marks here, which don't always come up, but it is worth putting in there. All they've done is they've spoken, like we said, about hydrogen ions being formed and hydrogen ions turn into gas. They just talk about the fact that it's the zinc that loses the 2 electrons to the 2 hydrogen ions. I mean, realistically, if you hadn't put that lost there from zinc to hydrogen, you would still get the mark, but worth bearing in mind, obviously this has come from a textbook, it's not come from an official exam question, but worth bearing in mind there are different variations of questions out there. So I hope that's helped. Key points to remember, really you can see here in terms of picking up marks, you're gaining your most marks here in terms of equations from your Ionic equations, and your half equations, again 1 mark each. This 5 mark question doesn't always come up, or definitely not often in exams, but they do arise. Lots of the time they're kind of 3 or 4 mark questions, so it's good to have a 5 marker here to show you the really specific language that will pick you up those extra marks.